How many moles of oxygen react with hydrogen to produce 27.6 moles of water? There are two ways to solve this type of situations: the conversion factors and the Dedondier ratio. The first being the most classical way to solve this kind of situation. In both cases, we will need the stoichiometric number to come out of a chemical equation adjusted by the law of conservation of mass. In the conversion factor technique, we take the data they give us and multiply it by the ratio of moles. These moles will have the identity of the associated substance, so in the denominator the moles of the same given substance will go. So we will need moles of water in the denominator, and in the numerator we will have the moles of the substance we need to compute. So we will need moles of oxygen multiplying. At this point we will need the chemical equation adjusted to the law of conservation of mass. So for one event of reaction we will produce 2 molecules of water, and we will need for that 1 molecule of oxygen and 2 molecules of hydrogen. Now we can state the mole ratio. We need 1 molecule or 1 mole of oxygen to produce 2 molecules or moles of water. Now we can cancel out the alike units, so the answer will be given in moles of oxygen. So we can solve the question. Now we can compute the value. We input 27.6 between 2. The answer to 3 significant digits is 13.8 moles of oxygen. In the Dedondier ratio technique, we state that the ratio between moles and stoichiometric numbers is constant between 2 substances in any chemical reaction that is not reversible. In this case, oxygen and water. So we can solve for amount of substance of oxygen and solve like if this would be a Gauss law situation. We will seek the stoichiometric numbers in the chemical equation. The stoichiometric number of oxygen is 1. Meanwhile, the stoichiometric number of water is 2. The stoichiometric numbers are dimensionless quantities, so we have to solve only for the value without units. Finally, we solve for the amount of substance of water, 27.6 mole. In this case, the dimensional analysis is simpler because the stoichiometric ratio is dimensionless in this case. So the only input unit is mole, and therefore it will be the only output unit. The arithmetics is the same as in the conversion factor technique, 13.8 moles of oxygen.